Hey guys, welcome to another video on physics. And this time I will be telling you the steps that you should take in order to ace your A-level physics exams. Now, one thing you need to know is that A-level physics is not as easy as you would think at first glance. But neither is it as difficult as you might come to see when you actually start your preparation. And this might seem like an anomaly to you, but it is not. So for those of you who have just enrolled into AS, what should you be aware of? You should have a copy of the syllabus content with you. Now, why do you need to have that? The reason for that is because at A levels, we don't have just a set book. We have multiple books by various authors, and all of them will have their pros and their cons. So what you really need to have with you is the syllabus content, which is sort of like what has been written by the people who will be making your exams. So you need to have that with you. And you also need to have a basic awareness of what AS in A levels is and what sort of exams you will be appearing for, stuff like that. All of this can be found in the syllabus. So I guess the one that ought to be relevant to you is the 2019 syllabus. Right, so stuff you ought to know. AS is very much difficult compared to O levels, but it is also considerably easier because by the time you're done with O levels, you have found yourself. You know how to study, you know the basics of all the various science subjects. And if your basics happen to be pretty strong, you will find, if your foundation is strong, you will find it very much easier to construct the rest of the tower. So, there's plenty of stuff over here. In the contents are all of the topics that are included. And over here are the exams you will be sitting for. We have paper 1 MCQ, paper 2 the structured questions, and paper 3 the advanced practical skills. In AS, which is the first year, you're going to have to be preparing for these 3 exams. So which is the most difficult? In my opinion, paper 1 is considerably more difficult compared to paper 2. The MCQs rarely repeat, and they're very unique, they're very difficult, and they're really testing your concepts to the core. They're going to ask you difficult questions which will begin to appear easier and easier as you go through the course, as your concepts solidify, right? So they aren't really that difficult, but for someone with, let's say, wispy concepts, they will seem very difficult, but for someone whose concepts are clear, they will be very easy. Paper 2 is comparatively easier. The structured questions do have a bit of repetition in the sort of stuff that is often asked, right? Like there's always a space topic, and oftentimes definitions are asked. And the theory questions are often repeated, just different wording, a bit of more unique scenario, but like almost the same thing. Now paper 3 can be a bit tricky, because literally any experiment can come up. You don't necessarily have to have done it before, or it might not necessarily be related 100% to your syllabus. But don't fear, it's never that difficult. In the question paper, literally every step in the experiment is written down clearly. What you need to do and how you need to do it. And in most centers, all of the apparatus will be available in extremely good conditions. even the examiners are more than ready to help out if you mess up a bit. They're very helpful. And there are these few topics that are often repeated. The pendulum one comes out like in different ways. Sometimes it will be a basic conventional pendulum. In the other one, we'll have the stick that is somehow like part of this bracket, and it's supposed to oscillate. So the principle is the same. What you need to do is basically you need to make the time period. See, but the scenario is pretty different, and it might seem a bit tricky to set up all of that. Anyhow, it will become easier. All of the steps will be written. When you will do one step, it will automatically become clear how to do the other one. Anyways, don't sweat on this. I will go back to this, to the different components and how to do this by the end of this video. But let's now proceed to the other parts. This. Number one, the first thing or the second thing a student needs to do is to have a good book. Now, the book that is most commonly used in Pakistan is this one. Cambridge International AS and A-Level Physics course book by David Sang, Graham Jones, Gurinder Jada, and Richard Woodside. Apologies if I mispronounced any name. Now, if you look at this book, it is very good in the sense that it closely follows the syllabus. The bad thing is that it's a bit too basic. If you were to just go buy this book, you would think that A-level physics is child's play. It's not. The good thing about this book is that when you go over this, you have a solid idea of which topics need to be covered, right? Say, you'd see that in this book, they've given the simple harmonic motion graphs, or that they have given the three equations of motion. Now you're 100% sure that you need to know these for your exams, right? And the second good thing about this book is the self-assessment tests, as well as the questions that are at the end of each chapter. They are extremely good. And the answers to that questions can be found with the attached CD resource. And if you don't have that, I'll probably put a link in the description for that particular CD resource in the soft form. These are the two things that are good about this textbook, but you should not be depending on this 100%. Got it? Now, this one over here is Pacific Physics A-Level, and there are two volumes, Volume 1 and Volume 2. And this is a great book. The problem is that it is pretty old. I'm sure the latest edition is like 15 years old. And there's a lot of stuff in it, a lot of which you don't need for the A-levels, at least right now. So you can't use this as a main textbook. You can find specific topics from the syllabus in this book and go over those only. Because the explanation is very good. Sometimes they give these excellent scenarios, and you would find that maybe this is a favorite book for the examiners, because oftentimes there are questions that come up in latest exam papers and they closely resemble this book, which was written way before the papers were made. Another good thing about it is the exercises that are found in this book, and the questions, they are very difficult, much more difficult compared to the ones that will come up. But if you have time, you can try doing them. Some of them you will be able to do them relatively easily, and that they were difficult conceptually, but you had this good grip on the topic. And many of them, even if you weren't able to do them once, twice, or on the fifth try, and you ended up looking at the solution, at the answer, it would still serve you pretty well. You can find these easily from old bookstores and stuff like that, but I'll still put a link for it online where you can buy it online if I can find it. Now the thing with this is there are indeed some topics that are pretty difficult to understand. For example, the digital sampling topic in A2, I found it pretty difficult. Even now I have a bit of trouble. So for that, there are a couple of channels that have lectures on physics. From A-level syllabus, from CIE, for AQA, and for OCR, and this, I believe, is the best of them. Dr. Physics A YouTube channel, and all of the detail is over here. And another one which might be the second best in my opinion is Science Shorts. Alright? So the best site for past papers is gceguide.com. So actually, let's go over this. My apologies. This is Dr. Physics A, and we have a lot of these videos over here. Some might be irrelevant, but a lot of it is really relevant. There are both for GCSE and for A-levels. Right now we have GCSE in the beginning, but we're going to be getting to the A-level part soon. Yep. Digital imaging, potentiometers, capacitance, any topic you have trouble getting, you can watch the video from over here. It's free and you can ask questions in the comment section. And this is GCE Guide. This is the home, and this is one of the sites that are the first to upload the exam papers. But if for whatever reason you're not able to access this, or some past paper is unavailable, you can use papacambridge.com. So you go to past papers and you click in Cambridge International AS and A-levels. And here we are. Where is physics? It's over here. And you need to know the paper codes as well. Physics is 9702. Bio should be 9700, stuff like that. And yep, we have the February-March paper. We have, my apologies, we have literally all of the papers. And yeah, it's a pretty good site. There's some other stuff as well. There's this attached community. Some of the books are available online, as well as CE resources. Right? So pretty much all of them. Now, another thing is that mark schemes are very important, and even more important are examiner reports. A lot of students don't really take examiner reports into account, but in my opinion, it was one of the greatest resources I used to guarantee my A+ grade. So we also have topical papers for those of you who want to do questions topic-wise. And then the community, which I haven't actually used that much, then CD resources. We have a couple of books. And there were a lot more, but a lot of them were simply removed. Here we have the textbook available as well. Kind of sad, I always kind of like these. In resources, we have notes. And if you look at the notes portion, we have for both AS and A-level, sadly. I'm not really sure if I checked this out before. So we have them, unfortunately, they're not completely compiled. Now, when you're doing past papers, the mark schemes are great. and the examiner report, but sometimes questions are so tricky that you're too messed up. Now this is the way to go. Physics reference has a huge amount of the questions for the past 10 years, maybe 70% of them done with complete explanations. And these are really important when you're doing the MCQs, because sometimes have the reasoning given, but the reasoning doesn't fully sit well with us. Over here, the admin, the person who has made this website, he has detailed the majority of the MCQs, all of the explanation, the whys and the hows, and this is simply great. So if you have this particular question, MCQ, what you can do is you can copy and paste like the first 5-6 statements, put it into Google and search. And often than not, this is the website that will come up. You click it and there will be a solution. Like, let's see. We have this question over here. It's pretty complicated looking, and over here we have the explanation, and it's simply great. Even the most difficult questions will be explained so well, you'd be like, wow, this is great for MCQ. Now this is another, we have this another site, and that's for this is a reference site in case some concept doesn't make a lot of sense to you. Unfortunately, it doesn't have all of the topics, but it does have a lot of them. You go to concept builders, it even has interactives. Like you have a bit of trouble with 1D motion, one-dimensional motion. They have all of these subtopics, distance versus displacement. Sometimes they go a bit off route, but still a valuable resource. Right? Then for practice, what are the best sites? Well, past papers are a good way to go, but I tend to like put them for the last 2 to 3 months in which I just do the past papers. Before that, when I'm actually sort of like building my concepts, I think questions are a good way to do that. Or physics, because you know the theory, but it isn't necessary that it's in your head. So doing questions in that period is really good. Like you've done it, and you use all your knowledge to try to do that, and then you have an idea what has gotten in and what hasn't. So what I do is there is this site that is called physics and maths tutor.com. I'm not sure where it is. I'm going to have to find it, unfortunately. We have it over here. So let's see, you want to do physics. You click the physics portion over here, and you have all of these options, right? So what I do is, I just simply go and click International A-Level CIE, right? Apologies, I guess it hanged for a bit. Now, these are from the past papers. So from CIE, these are worksheets that are made from CIE past papers, but over here we have capacitance, but this is for AQA past papers. And only those questions are included from the AQA that are also relevant to CIE. Sometimes they mess up, but mostly they don't. So we have this. And we have from Excel, and we have from OCR as well. And if you do these, it's more than enough practice. If you want to go overboard, I'm going to find some other resources and post it as well. But these ought to be enough, right? There's this another one, but Save My Exams, but it's a partially paid resource, and physics and mathstutor.com definitely trumps it. Anyhow, this is great. The answers are also available for most of them. Over here, marking scheme, marking scheme, marking scheme. Notes are Z notes. They're concise notes. You shouldn't really be just depending on those, but it's a good way. Now let's get back to what I was saying. Let's go detail about the components. P1, we have 40 MCQs, and we have 1 hour 15 minutes. This is one of the most difficult parts of the physics content. You need maximum practice with MCQs. And you need to be able to juggle your time well. You need to have these tricks. Sometimes the question is so difficult you can't solve all of it. So you're going to have to rule out the other three and reach the conclusion. It's more of a mind game than physics. Definitely, good physics concepts are involved, but you won't be able to do them if you don't have an alert mind and the ability to see through deception. Like if I were to show you over here, let's see. Oh man, the video is getting a bit big. My apologies. M18 question paper 12. So I'm just going to orient you with. So you have these, this data available, stuff you don't need to memorize, and these formula. And you'll have these questions. And some will be theoretical, but most of them will not be. There will be a bit of repetition, but largely there won't be a lot of it. So this is what you should be, emphasizing on. For P2, we have a lot more time on our hands. I guess we have, my apologies, we don't have a lot of time, but it's very much easier. We have all of these questions. Now, the part that is difficult are the questions. So I'll read this out. You have 2 questions and you have like 2 hours. So in this experiment, you will investigate forces on a wooden strip which happens to be in equilibrium. Right, so this is the one that is in equilibrium. And before that, none of the students would have ever seen this apparatus. And you might feel a bit overwhelmed, but calm yourself. So they're saying you have to adjust the height of the boss and the position of the mass until the wooden strip is parallel to the bench and the springs are vertical. Well, a student would not have seen this particular arrangement. They probably would have at some point done balancing experiments. So you need plenty of practice, practical experience for you to be able to do this, but it's not hard. You have to measure and record the lengths L1 and L2. Again, not really difficult, but you have to be really careful while doing this that you don't disturb the apparatus. You have to note these down. You're provided with a wire hook and metal rings, and the card shows the mass of the hook and the mass of one ring. Hang the hook and about half the rings from string loop Y over here. So we're going to have to put this loop and a weight over here. So you have to record the mass hanging from the string loop. And you're going to have to change the value of M by altering the number of rings on the hook. And repeat all of that which has been mentioned, and you need to draw this table. The drawing tables is a very important part of this, and it's really easy, but you have to be careful. It has to be neat. The headings need to include the physical quantity that is being measured and its units. And everything in one column at least needs to be to the same precision, the same accuracy, the same significant figures, and how much significant figures you're going to go with needs to be decided based on the type of experiment you have, the values in the question paper, stuff like that. Another thing is that you have to then draw a graph. Now, again, you're going to have to be very neat about it. You have to, like both the axes need to be written down the correct units. The scale has to be chosen wisely so that the graph that covers like the majority of the available space does not exceed it. There shouldn't be any point that is outside all of it. You shouldn't be missing out any point that you've mentioned in the table. And you also need to know how to draw a line of best fit. There are plenty of videos on the internet about that. And gradient and y-intercept, that is pretty easy. But you need to have a lot of practice with drawing graphs and making tables. And this is easy. You're just going to have to, you know what y is equal to mx plus c is, and you need to be able to resolve that according to it. You're going to have to compare this. You'll understand when you finally do this. And from that, then you're going to have to do this. So the experiment part of it is very little. It's what you do with the values that you achieve, which accounts for the majority of the marks. And this is similar, except for the second question, we have this part over here. We have to tell the uncertainties and the ways that the experiment could be improved, right? Like they've given the way you have to do this, but you're going to have to tell an alternative way that might have made the readings more accurate or more precise. You're going to, like with time, going to learn how to do this, how to improve experiments as your knowledge of practical physics increases. At the end of Physics A portion, we have this really important chapter on limitations and accuracy. You should read that. So this is literally just practice-based, as much practical experience as possible, and even more experience making graphs and making tables. And for this component, the examiner report is the most important. After doing all of this, read the marking scheme, compare with your results, same with the examiner report at least twice, wrote down all the points you missed out, highlight them. You need to have, at least for this, the examiner report and the marking scheme in printout form, printed out. P5s is all same like ADP, like you did in O-levels, except it's much more difficult. You're going to have to draw stuff, make an arrangement of your apparatus in the first question. And you're going to have to detail sort of like a lab report, what you did, how you did it, what sort of errors you may have incurred. And this was, to me, the most difficult part of physics, even though this was in A2 and I was very much experienced by then. So I've made these videos on like 14 different topics. On question 1, which is the most difficult, this is the playlist. Please take a look at it. Hopefully it will make everything way easier for you. The second part of P5 is simply you're going to be given values. You're just going to have to make the graph and then, do stuff from it. So that won't be difficult. You're going to have to do it a few times and you're going to get the hang of it. It's the first part of P5 that is really tricky. I'll even show you one of these. I can't seem to find one. S16, question paper 52. And good thing is that there are two versions of each year's paper. May, June, and October, November. And recently February, March as well. And for each of October, November, and May, June, there are two versions. 2 and 1, like 51 and 52 for each component for different areas of the world. So all that more practice. So they have given the statement that this is how it is, and that is what you need to be able to do. And these are all of the stuff you have to include while you're telling the examiner how you're going to do this. I have all of this, the details of this explained in my video, so please check it out. So hopefully you found all of this to be helpful. If you did, please like, subscribe, and leave a comment